everyone, my name is Amira Darwish and this is Project 3 for Megatronics under Dr. Yasser Ismail. In this video, I'll explain the homogeneous transformation matrix and how we derive it from a rotation matrix. This matrix is crucial for combining rotations and translations, helping us model robot movements in 3D space. I'll show you how it works using a two-link robot arm example, highlighting its importance in robot control and motion. This is the Python code that we used to calculate it. I'll go ahead and explain the code. The first part, import numpy as np, imports the numpy library for matrix and array operations. For this second part, it defines the link lengths of the robot arm. A1, we measured it by a tape. It was 5 centimeters, A2, 6, A3, 5.5, A4, 5. For the third part, it defines the joint angles in degrees. T1, we're doing it 30, and T2, we're doing it 90. In this part right here, it converts the joint angles from degrees to radians. And then moving on to rotation matrix from frame 0 to 1. This constructs the rotation matrix from frame 0 to frame 1 using T1. And this part is doing the same thing using T2. And then right here in position vectors, this defines the translation vector from frame 0 to frame 1. The first one. And then the second one defines the translation vector from frame 1 to frame 2. After that, we're doing the homogeneous transformation matrix. This concatenates rotation matrix R01 and translation vector D01 to form part of the homogeneous transformation matrix H01. In this part, it forms a part of the homogeneous transformation matrix in H12. And then towards the end, it prints the matrices H01 and H02. Finishing up the video, we're going to see if our Python code runs. And as you can see, it's working. We're going to get back to this later on. And then we can go ahead and check out our PSOC code. So for the PSOC code, I actually used the code that we had for Project 1. It's the same thing. All we got to do is get rid of this and then change the angles of theta 1 and theta 2 to 45 degrees. It's the same code that I had for Project 1. So this is the two arm servos that we used for Project 1. Servo 1, Servo 2, and then we're using a pen to mark. And then the PSOC, breadboard, and our external power supply. All right, after running the program. All right, we connected it. PSOC turned on. Program. All right, as we can see, the servos moved. Servo 1 did a 45 degree movement. Servo 2 did the 45-degree movement as well. We ran out of ink in the pen, so that's why it's not showing. But this is how it's supposed to look like. So for the last part for my video, I went ahead in my Python code and changed the joint angles and degrees to 45, 45, so we can calculate the rotation, the homogeneous rotation matrices at the end by running this code. So we're gonna run the code. All right, and all right, so this is the output. I'm having some technical issues. So this is our output of the code, and our Python code is working. Right. Thank y'all for listening. Have a great day.